6458, runway 2. One to it left, 2458. Guys, 6478, runway 28, right, line point. Making that is 2611, cross to your left, hold to your right. 2611, cross to your left, hold short to your right. Cross to your left, hold short to your right. Number 5, Charlie Bravo, right turn, Papa, or Lima, join Charlie, ground 18. November 889 Air Public Throttle, clear for good guy, with C63 and C3, cross 29, runway 2 right, clear away. No, something, United 26, ground 4 buttons, ground wheels up on this one. W616, and right turn, contact YOU-NEE-FORM, Archer,
This is the live conversation going on at the air traffic controller. This is at the San Francisco Airport. Hard to understand that. So let me start with the environment. This is Stanford. Stanford campus at Redwood City, and I'm using their Wi-Fi. So let's give a credit to them. It's so windy, so that is it. So this video is all about air traffic control. So what I started learning was studying about this domain. It is totally new to me. So I started studying this domain a few weeks ago. So I asked, we have an alumni group. All our friends are, we all studied together in that university. Some of them are electronics engineers, some of them are aeronautical and automobile and instrumentation and production. I was at the electronics, so, and I started with the hardware, then I entered software. Software also application development, not on the system side. So what I initiated the discussion with my friends. But I asked them, has anyone worked on avionics? I need information on air traffic controller, ILS, instrument landing system, and VOR, VHF, Omni, radio, and any other from your field. I started the conversation. And this is an overview. I'll give the entire overview on this topic. Then I will actually add other chapters. That's what in YouTube they said, chapters for each context. Actually, instead of chapters, it is a context. Should be the right one. So I'll add content, and that I'll share those content. This one I'll just give a overview without any presentation, just talking to initial conversation. And there's a lot of resources available on the YouTube, especially on the YouTube. And then the documentation from the Federal Aviation Administration, FAA.org. They have very good publications and documents. What I did, I used Google Notebook LLM because going through all those manuals and then the audio recordings. It would have taken a few months or years without LLM. But this one, I use Google Notebook LLM and have actually uploaded all the documents, whatever I am having access, I uploaded. And then I asked for summary and other contents. In fact, they have an audio overview also. It was pretty good. So I used extensive that. And I also used Meta AI as well as Grok. That's from uh, X platform to get a coding. Yeah. Uh, I have got the audio file. It was in MP3. There was a conversation, a air traffic controller and the pilot conversation. It was an audio file, and I wanted it because it's very hard to understand the conversation. I want to have a audio to text conversion. I got it from the notebook LLM, but from the coding wise, I tried it. I asked for a coding, Meta AI as well as Grok. They give exactly the same. Only thing Meta had a syntax error. The try block was not in a proper place. But otherwise, both of them are calling the Google Google API, voice API or synthesizer or something. Uh, so, so coding is nothing much. So all the software is now become like a calling a API or using a framework like a PyTorch or those kind of the things. So application developers, all they need to know, they have to get familiarized with the framework and then the API and then the right way of calling. That is important. I don't want to go too deep into the Silicon Valley technology. I want to go to the domain part. But since this is favorite, I'll cover these parts. Uh, so, so then I came across, the Lang chain built a Lang graph. I don't know why they call that a graph. It is an orchestration engine, uh, and especially the latest one I saw that there's a swarm architecture, and then um, the example they use, a user who would like to do a flight booking. So they have a flight booking agent. And then there is another agent for hotel booking agent. And you can start with any of those agents. And then you can actually transfer state from flight booking to a hotel management, hotel booking. So I covered all these things because these are all going to be part of this video for the air traffic controller. Yeah. So let's have the context and then have a boundary. And the scope is limited. This video is limited for air traffic control. And after a few weeks into it, I see the challenges, the current challenges, and the opportunities. And I could confidently say that this is going to be the. So you guys, yeah, even this is Stanford. Yeah, I don't know. Somehow we are, yeah. So you guys have invested. $100 billion or something more than that on the AI research. Started with the machine learning, then deep learning, neural network, recurrent neural network, convolutional CNN neural network, then transformer, then LLM. All these research have developed many products like a voice to text, text to voice, then video to text, video text to video. So it is all those individual routines or functions. Those are all have a value. So when I started programming, the very first time I went to a computer center and started programming. When I was there in the college, so we went to a computer center and we didn't use keyboard. There was no keyboard, there was no mouse, there was no video display terminal, no scrolling, nothing of that sort. And not even an operating system. Yeah, not even an operating system. We punched cards. We punched cards and then gave the cards. We wrote a Fortran program. And then they gave the cards to Factorial. Yeah, maybe a Factorial. For our learning purpose. And even the payroll, they were running the payroll and then university mark sheets. Those were all use the punch card. And I have seen a computer, even without a punch card, they directly have a front panel with a toggle switch, 1 or 0. You set address and you set data, and then you write a assembly program on a paper, and you do a hand compilation, manual coding, like move A to B, A from A register to B register. So there is a code, hexadecimal code. You write it, and I seen a computer which doesn't have a hexadecimal code, hexadecimal keyboard. It was just a toggle switch, 1 or 0 thing. So I have entered those programs and then effectively executed. And so it is not that computers always had a operating system and keyboard and then a mouse. And now, now the developers or whoever um, has they have built a very reliable voice communication. And that developers have to recycle their keyboard. They have to talk to the computer. Okay, import PD from PyTorch. So that should be a voice instruction. So that is how it has to be. It is yeah, you have matured that level actually. So what I'm confidently doing is that because I did the same thing in 2009. I was there consulting at Google in 2008. Uh, yeah, I used to say Google is a Willy Wonka chocolate factory for software developers. So that was the first time I've seen those food court and then the variety of food. It was a, it was a wonderful experience. 2008, so many things were happening. It was an election year. Barack Obama was and Hillary Clinton. They were all seriously fighting, contesting the election. And then the whole Silicon Valley were supporting Barack Obama. So that was the one part. And then the Apple launched iPhone. So Google was in a position whether to launch an iPhone or a platform or what they do. So they launched the Android platform. I was there at Google, and then there was a housing market collapse. So they were talking all, even CEOs, Rick Smith was talking that we have hit the bottom, or so everybody was lost their hope. Everybody was talking about depression, economic depression or recession, all those things. So there were so many things were going on in 2008. And at that time, uh, Google launched the Android platform, and to promote the platform, they have announced developer challenge. I was not sure what to develop, and I was not sure whether even if we develop in any application, will it work on a mobile? That time it was, I think, G1 or something from HTC. So that was the first time I got into T-Mobile also. So I was not sure any application will work or not. So I want to, okay, I saw that I didn't even have a iPhone. All my friends in the next cube or sitting across in the same hall, they had an iPhone. So I asked, what is, I asked about what features it has. What is so special about it? And then they had iPhone. They were all using it for only for voice communication. They didn't even try it. They thought that it has a browser. It had a browser and it had a Wi-Fi. They said, well, why should I go use a Wi-Fi here? I asked them, okay, can I try it out, the Wi-Fi? So I took their phone and then connected to a Google visitor Wi-Fi, and I was trying it on. I was gaining confidence in it. Then, but still, then without a infrastructure, wireless infrastructure, how could this will work? So I had my doubt. So I want to experiment. I want to validate the concept whether the you go on the road and then use something because that time web was available at home. You have a desktop or laptop computers, and then you use the web. And then web was available at work, uh, but it is not available on the go. So I sensed it. There was a need for uh, web on the go. So later, when I published a book, that was the title, uh, Web on the Go. Uh, so, 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 so I sensed it. There was a need, unsatisfied need. Later, I understand that is what we need to do. We have to go into the domain, different domain like agriculture, ocean, transportation, security, retail, manufacturing, logistics. To go into different domain, nobody, even if you start with the punch card, everybody was using punch card and nobody asked for any dump terminals. But someone has identified there was an unsatisfied need for dump terminals. So dump terminal means it doesn't have any logic. It just take your keyboard entry ASCII code and then send it to the mainframe computer. So someone has sent unsatisfied need for dump terminal, then they provide us. We started using it. Then we were satisfied. Then someone has sent the need for computers at home, personal PC. Uh, so so that was an unsatisfied need. Then the networking, internet. So then the wireless. Now, now it is artificial intelligence. We need to identify the unsatisfied needs of different domains. We have to go into each domain. So this is one such part. So coming back to 2009, I had my own doubt whether the mobile will work or not. So uh, coincidentally, that time in 2009, Google provided a free Wi-Fi in Mountain View City. They went to San Francisco, but it didn't work. They couldn't. They had issue or problem with the government executives. But they provided a free Wi-Fi for the entire Mountain View City. What I did, I took my laptop and connected to the Mountain View City Wi-Fi and took my laptop on my minivan, and launched one YouTube video. I could see that, yeah, it was coming perfectly. And I want to see the same performance while I was going around the city. So I was driving around and I was so surprised. And it was shock also. It was working perfectly well. Yeah. So, in fact, I tried to launch uh, multiple YouTube videos from different browsers on a same laptop, and it was all working perfectly. Then I gained confidence. Okay, so there is a infrastructure, and this it will go very well. Then, uh, yeah. So uh, it's naturally when you have your when you observe and uh, in your from your daily activity. See, I'll give you one example how it happened. So I went to work. I forgot my badge. So I had to go to the front desk and ask for a temporary badge, and that will work for a day. I went there. I parked my car and then went to the front desk. It was in one. Each building has a front desk, and then they have a person who provides a temporary badge. And it works for that day, and you have to return it when you are going back in the evening. So it works. So I went there. I saw that almost 10 persons were standing in the line. So in that building, around 100 people may be working in that building. 10 people were standing in the line. When it came to my turn, I asked them, is it only today or every day it's like that? And that person said, almost every day, 10 or 25 also. They keep forgetting their badges. And it is in one building, and they have a multiple building. Almost each building has got people forget their badges to work. So that was a challenge. That was an opportunity. And I asked them, So why don't we have the badge on the mobile? Okay. So all you need is an identifier. So, instead of um, uploading the code for developer challenge, I prepare a document, Word document. Okay, I like to have my badge on the phone, and that gives a authentication to enter into the. And even Google has got many different locations. Some of them are restricted for higher executive. So all those restrictions, they everywhere they have that RFID. So that you could have it here, and that should work. So anyway, I'm going to have them. That could be extended to my Costco card. It's only now Costco has implemented. Uh, I published in my book in 2009 that I like to have a Costco card, my credit card, and my work badge, and the green card, and even the passport. So that is how those are all unsatisfied needs. You have technology. You cannot expect the Silicon Valley technology engineers to understand all these things. They have technology to solve all the problems in the world. They could they, they could solve it. Only thing they don't know what problems are there and what are their priorities. Yeah, someone has to do that job. So I thought that I'll take that responsibility and have published the document, and it worked very well. I could say that most of them, even still now, many of them has not been implemented. So in my document published Web on the Go, so it is a vision document, and then I captured. It is a fiction. It was a fiction. I just highlighted the current challenges. Because now we take it for granted. We take the mobile and go to any countries, and it will work. So it was not there in 2009. So I wrote one story on that. The cell phones do not work in other countries. And now the wherever you go, the hotel is offering a free Wi-Fi, so it works. So you don't need to have a mobile network, but at least the Wi-Fi is available at the airport, train station, uh, on the bus. So on the go was so I gained confidence in that. So I'm actually doing the same thing for artificial intelligence. And I could confidently say that all your investment on $100 billion investment and 100 plus beautiful minds. This is a amazing technology and innovation. This is a wonderful one. And you guys did a excellent job. And it's time. So I have a confidence in the, just like I validated that network, free Wi-Fi, citywide Wi-Fi. So I validated all the LLMs, all the large language models and other frameworks. And I'm now confident to take this technology to a production level for real life application. And this is, I could sense that the air traffic controller would be a breakthrough, and it is going to be the first production level artificial intelligence application. And I could confidently say that the current professionals working on the field as an air traffic controller, ground or tower, I learned all those domain knowledge recently. the current professionals and also the students who is now studying in the academy and also the retired professionals and the pilot, they all would yield their professions to machines. So in all other places, there may be a sense of security or a sense of losing their job, but this position, they would welcome it, they would love it. Artificial intelligence working as a air traffic control. So that is so it is going to be a breakthrough and a production. Your technology and everything has matured, and especially in the voice communication also matured, listening and all those things. Yeah. So this is now confident. So you can actually deploy into a highly challenging environment like aviation. So, so let's go deep into the domain. Now, yeah, now all those technology side is over. Now, let me go deep into the domain. Okay. So, so that at the beginning of the video, I played that audio. It's not a recording. It is a live audio feed from San Francisco Airport. You can it's a RF frequency. You can tune to that frequency and then listen. Anybody could listen. Only thing you won't be able to talk to them. Only the pilot and they will be able to talk to them. But anybody could listen. So that was a live feed, and so uh, so it's all at the airport. So I have I have listened or I have studied about four different airports. One is San Francisco, then other one is Dubai, then Mumbai, Bombay in India, and Skardu. Skardu is an airport. It's on the Himalayas. On the Himalayas. Why I mentioned that they don't have a air traffic controller. So there are airports. They don't have a air traffic controller because the traffic is less. One flight a day or two flights a day. So they don't have these challenges, and they have a very wide runway. I think 3 runways they have, and pilot if you have a clear visibility could land uh, without any issues. Only thing reaching there is much more challenging because of they say Zulu. Zulu is referred to Z. So those mountain peaks on Himalayas, so they have to go through that. That was the only challenge. But all these places, San Francisco, Dubai, Mumbai, and that place, they have a ground air traffic controller and then the tower air traffic controller. And um, they use computers not for, uh, it's only for stacking which aircraft is uh, uh, on the line, which aircraft has to go or next. So that stacking they use computer, but otherwise they don't use it for control purpose. Um, So that is what San Francisco and Dubai also use the computers. They see the screen and they have a horizontal stacks. Each stack has got the flight number and then the runway and then the time to depart, that information. In so earlier, all the airports were using a metal rectangle metal piece for each aircraft, and they have the vertical stand, and they keep those things, the metal bars, in a stack. So and incidentally, that kind of the metal and then the paper and then the writing on a ink. That is what even now they use it in the Mumbai airport. So that part of that is not going to have computerizing. That part is not going to help. So it is all the aircraft movement on the ground and takeoff and landing and in transit. Uh, the entire thing depends on human. Pilot plays a major part, but the landing and takeoff, the navigation and the guidance, this completely depend on human. And so to qualify air traffic controller, um, I saw that Elon Musk is asking for all the retired air traffic controller to come back to work. But the qualification is that uh, should be less than 30 years. Uh, so they won't have that young people because it's all active listening, and then it's their judgment. they, they make the decision. The very the flight is going to land. It's around 15 minutes. The flight has got a crew of 4 people. Then they call the traveling people as a souls, 200 plus souls on board. The entire thing of of that 200 plus 4 souls uh, of of their life and death. That responsibility is on the air traffic control for that 15 minutes. It is it is not worth it. Even whatever you give your salary, the kind of stress and tension on those people, that's a very so so even for smooth nothing happens smoothly. I have gone through all the uh, uh, recordings, most of the recordings. Every moment is highly tense. It's not like we make a null pointer exception and we go home and sleep. It's not like that. Their null pointer exception costs the lives of 200 people. So, so it's not it's a high time. We need to take off the load from human, and then the machine needs to take the responsibility. And AA is qualified. So you see that. So they still it's completely manual human uh, responsibility. It's not a computer or they use all the technology only to support them, but the action and the decision they use all the ILS and then the radio RF frequency is only for communication. but it is all depends on each individual skills, and then the decision. And the 30 years age worked earlier, but now the 30 year age is in a very confused state. And it is too much. It is too much we are expecting from them. So let me just cover all these points. Almost all are the same situation. San Francisco, Dubai, Mumbai, and Skardu airports. Almost all are the same. They are in a different country, different location. Technology-wise, different technology. Someone even Mumbai is using paper and then the metal uh, container, metal holder, but is all same. Almost all at the same situation. ATC, air traffic controller, operations are manual. Humans are responsible for a safe movement of the aircraft on the ground, on the taxiway, on the runway, takeoff, on the air and landing. So at Dubai, they use computer to display the stack of aircraft in line, and they use touch screen to clear one at a time. At Mumbai, they still use rectangle metal holders to keep the stack of cars and use pen to update the status. Even the pilot are using paper and pen when they are talking, and then they are writing it on the paper. At Skardu, no ATC, no tower. It is a responsibility of the pilot. It is a remote airport on the top of Himalayas with less traffic, so that was okay. Ground ATC and tower ATC and the pilot conversations. So it is a chat application. It is a conversation. It is a chat application. This would be the first production grade artificial intelligence application to replace human beings. And ATC professionals would yield this job to AI. It is a highly stressful job. It is worse than a soldier on the warfield, battlefield. It is worse. So every day, every moment, they are dying. It's not. I feel. I feel sorry for them. For every flight during the takeoff and landing, ATC are responsible for the life and death of the crew and 200 plus souls on board. One of the qualification is age, less than 30. Now the government asks retired professionals to come back to work. The current generation 30 plus have issues at home and not in stable condition. ILS, Instruments Landing System, VOR, Very High Frequency Omni Range, DME, Distance Measuring Equipment, all depends on radio frequency. At both ends, on the runway and also on the aircraft. They need to have a ILS equipment. Client side we used to say that, but they have to have a receiver on the airport. Then only they could able to use that on the runway ILS form. See in one incident, yeah, I'll come here. So okay, so AI, this AI is Air India, Air India, Air India flight 101 to New York Kennedy Airport. They had a APU, auxiliary power unit failure. They have ILS and all the instruments or equipments are there, but the power unit has failed. So because of that, they cannot use those equipments. So at New York, after a very long flight from India to New York, the pilot uh, reached New York City, and the weather was very bad. I don't know whether it's raining or snow or something. The weather was very bad, and the cloud also covered. So he doesn't have the ILS, so he cannot actually. The pilot couldn't land it. So that was a real life incident. They have uh, to have a visibility on the runway. They have to come below the cloud. The cloud ceiling was covering the aircraft, and if they come below the cloud, uh, if they the altitude is not enough, and if they are on a high speed, they'll crash landing. So all those skill challenges are there. I don't know. it is it is a miracle. Every landing, and they don't have an integrated system. So they get a the pilot is in conversation with the New York um, Kennedy Airport tower controller. Um, so at that time, the ATC gets an alert, weather alert. So the Newark Airport, in New Jersey, this is close by. That has got uh, the cloud is clear, so the visibility is better. So then immediately he asked the pilot to go to the Newark Airport and then alerted the Newark Airport also. So Newark Airport cleared their entire runway for the safe landing of the Air India flight. And then they had all the emergency equipments ready for in case of any failure, but it was a safe landing. So that is what is happening almost every day. Uh, so that is happening. Okay. And then, yeah, in 2009, when I was getting into the domain and then writing that web on the Go book, uh, I saw that every individual domain, they have their own data acquisition equipment and data control systems. All their proprietary. They have their own sensors, server, and then the network, especially for the logistics to track a shipping container. They place a RFID sensor on the highways, and then they were doing it. So I thought that since a mobile uh, platform is going to be available and then the infrastructure is available, now you have Starlink, satellite internet. So we could move all the independent data acquisition system to Internet of Things (IoT). So once because their entire thing is on the RF frequency. For in TCP/IP, we have that as a physical layer, whether it's a wire or a Wi-Fi wireless. It is a physical layer. We don't have a logic or control on that layer. We have physical layer, the network layer, then the application. So we have to move all these ILS and VOR and to Internet of Things. So that would be now you have you have a Starlink satellite. Internet is available everywhere. Network. So at least the network part is over, and you have voice. Now we are reliable. The voice AI is reliable. You could talk to a machine. If you have a AI-ATC, ground AI-ATC, the uh, pilot is having the flight in the gate C9, and he wants to go to a taxi, and then from the taxi to a runway. C9 in their language and protocol, it is called CHAR-LEE 9. So the pilot United 1469, 1469. So they have to say 1469. United 1469, reaching to, they don't need to use all these to, from, and for, all those things. United 1469, ground controller, ATC, request uh, request taxi, gate CHAR-LEE 9. And then the ground ATC response, United 1469. They have to repeat that. Uh, Hold on, or you allow or permit to move from gate to taxi. Your AI could do that now. So that part is okay. Because at least the ground part could have the a voice communication. It's basically a voice communication. Is okay. And so that part we have it. And before all these things, all the traffic controller, before they have the tower, a few decades ago, there was a physical, even now, even at San Francisco airport, there was a physical uh, person with flags or lights. They direct the flight to come or stop, or at least they brought the flight to the gate for a proper fixing. There's a human is working on it. If you are Optimus or any robots is ready, then they could employ that. They can actually on the field, not on the runway, but have a view on the runway. You could have a camera or at least a moving Optimus robot, because most of the problems, I was listening to those recordings every day, every airport has so many challenges. And most of the challenges are repetitive. Debris on the runway. That is one thing. And it happens all the time. Debris on the runway. And then the flat tire. And then all these things. Yeah. So even a bad attack, you have now autonomous vehicles. You have this light radar or something like a Waymo has got the radar. And then Tesla goes with the vision, volumetric occupancy. So you could have all those things on the flight, and you could avoid all those bird. You could sense that, okay, the bird is coming. All you need to do, you go altitude, just a altitude change, and then that will give you that thing. Then so all these voice recordings, uh, I tried it with the voice to text data. It gives a lot of event information. It gives the entity. It is a United flight, and the flight number is there. And you have entity on the pilot, and you have the entity on the traffic controller. All these entity and the timestamp, and then the nature of the problem. All these are available. All these things needs to be extracted and stored in database, not relational. All thing has to be go in a vector. Vector. They have altitude. They have different, even in 2-dimension horizontal runway, 8 flights of on the line. But if you have it as a vector, you know that, oh, okay, so it is safe. So they don't have all these things. Even even the screen, what they are seeing, all the flights are in transit. They don't have the vector. All is a dots and then the identifier and then the yeah, only those identifiers. And there we couldn't see that the physical because every flight is flying at the different altitude. So that real-time information has to be captured and it has to be vectorized. Vectorized. Now that is the thing part of that. The currently to start with, you could take all the recordings and then convert into a text and then train your model, and they could actually list out all the repetitive incidents. You could just ask for a summary and list of incidents, list of events happening in San Francisco airport. They could give it. So vector database we needed to have it, and we have to, and each uh, each trip uh, from the gate to the taxi and then the runway takeoff and then in transit and then the tower landing and taxi gate. The entire trip is one transaction and that has to go into a kind of a blockchain immutable record globally. So when you bring all these things to a internet, right now it's all one-to-one communication, and it gets lost. The pilot to a ground controller conversation, the tower doesn't have any information on that. So they are repeating all those things, and it's all one-to-one, and it gets lost. And the whatever has happening on the SFO airport, Oakland Airport has no visibility. They may exchange by audio, but so data, you go into a X platform and you see a global visibility, what's happening there, that kind of a thing. So we have to bring it everything into internet. Maybe the same security could be a different one, but they cannot have it as an individual thing. Okay, so that was the one. Let me cover all the other things. This is last but not least. Everything. You may have a wonderful technology. You identify the problem, the thing. So- but it demands a political leadership. For instance, Google wants to provide Wi-Fi for the entire San Francisco city. They couldn't do that because that time the political leadership, or the mayor or the government executive, they were not. They were following their usual protocol. These guys, Google guys, the engineers, they got fed up and then they stopped going for the meetings. And then I told them that you cannot ignore the political thing because they make the decision. so, so they play a crucial role. At this point, I have to mention this also because I have seen in 2009 the entire Silicon Valley went to Washington D.C. and they were part of the Obama administration. But that this time also Elon Musk has gone there. But what is the difference in 2009 and this 2025? 2009, Eric Smith went there, but he took all the project managers. and that, that, that time, that time they didn't even have a product manager. It's all project manager, project management. he took and they worked for some time, and then uh, Obama Obama has got both friends, political friends and then technology friends. His political friends said that it's not good to have these guys in Washington D.C. So Obama didn't actually cooperate with them, and then they came back. All of them came back, and then they said both parties are equally bad. So that was happened. That happened in 2009. But this time is different. This time is I could see that everything is in action. I give a credit to Secretary Sean Duffy. I have no idea about his profile, but I had a glance at his profile. He has a huge family of 8 or 9 kids. That is responsible dad, and he gives an effective leadership. He went to the Oklahoma Academy and then talked to them. And he asked for students to come and join the academy, and he highlighted the need uh, for for this and yeah, my battery is running low, so let me quickly fix it. So it is a common sense. President Trump is common sense, and is a political leadership secretary Sean Duffy. Because of his expression, I got deep into this domain, and I have worked on it. And then Elon Musk is all about intelligence. Intelligence. He takes intelligence. It's not accumulated knowledge. All these guys are using accumulated knowledge, but Elon Musk is applying his intelligence. Intelligence is all about observe, sense, perceive, and act. That is intelligence. So this is overview, and I'll cover all the individual items in depth. At that time, I'll share my information. Thank you, guys. This audio transcript captures radio communication at Westchester Airport following an incident. An aircraft Flex 333 landed on runway 16 and reported braking action as good to medium before another aircraft slid off the same runway. The tower coordinates with the other aircraft, including one needing to refuel and another waiting to proceed on the runway, while also assessing if there were any injuries. The priority shifts to removing the disabled aircraft with plans for another runway inspection pass before normal arrivals resume, highlighting the immediate response and adjustments made after an aviation incident. Let me play the audio and we'll also go through the script.
Good evening, Westchester Tower. FOKS-TROT 333 is on ILS-16.
FOKS-TROT 333, Westchester Tower 1110 at 8, runway 16 RVR, touchdown 4 and roll out 4,500. Drops are breaking out 900 feet MSL, and last breaking action report was medium, runway 16, go to land.
All right, clear land, runway 16, FOKS-TROT 333, thank you.
JEW-LEE 613, contact nearest departure, good day.
Departure 613.
FOKS 333 going to flex yet?
We're going to flex here. We're slowly getting slow.
FOKS 333, right, you could turn left at the end. And when did you pick up the field?
We pick up the field probably about, 3 miles out? 3 miles out. FOKS-TROT 333.
Roger, and how's the break in action for you?
It's good to medium for FOKS-TROT 333.
Roger, thanks, let's see any contact ground. Have a good day.
We're flying for FOKS-TROT 333.
Roger.
And we are off the runway, FOKS-TROT 333.
Chat 333, roger.
The flight is off the runway.
FOKS 333, we're coordinate with ops now. Dick Strike 580, unfortunately we just had an aircraft slide off at the end of runway 16. I'm unable to depart right now. Not sure how long the delay will be. Just say your intention.
We're going to have to go back and get more fuel reach already.
Alright, Dick Strike 580. You can turn right onto runway 16, right at Charlie, and then taxi Charlie into Atlantic West with me across runway 11.
Okay, we'll access runway 16, right on Charlie, then cross 11 to Park with Strike 580. Any estimate that you may have?
Not yet at this time, we're trying to work that out.
Oh, that's your Strike 580.
Tower, Airport 1.
Airport 1. Go.
Tower, Airport 1, holding short 16 at FOKS-TROT, looking to proceed on the runway.
Airport 1, you can proceed on runway 16.
Proceeding on 16, Airport 1.
Strike 1 dash again. Yeah, the runway's all yours.
X-ray is out of the chart. There's no wheels this time. We're in the blast pad and hooking up the tunnel.
2-4, Roger. And as far as you know, are you aware of any injuries at all? Roger, okay, so no injuries and any damage? Roger. Ops 39 Tower. 39, I do have aircraft holding inbound. Are you guys going to want to do more passes prior to starting arrivals up again, or what's your plan?
The plan is once they get that
Okay, so we'll plan for one more pass after they're off then. That works, thanks.
Tower 2-4.
2-4, Tower.
Yes, sir, that brief box actually on the move. He's able to be towed out of here. It was really, everything was on the pavement except the nose was touching that grass.
Roger.
That was the conversation between the pilot and the air traffic control. Let's stop. Yeah, this audio recording captures the immediate aftermath of an incident involving aircraft Iconic 719 during landing. And the primary concern is a suspected tire issue indicated by heavy vibration, smoke, and a loud pop reported by the flight crew. Consequently, the air traffic control tower coordinates with the emergency service, other ground vehicles, and the airline's operation to assess the situation, ensure the safety of the 4 individuals on board. They call them as souls, and 3 crew, 1 passenger. The emergency services and other ground vehicles and the airline's operation. So the situation, ensure the safety of 4 individuals on board and plan for the aircraft's removal from the runway, which is confirmed as having 4 flat tires on the main gear. The conversation highlights the collaborative effort to prioritize safety, gather critical information like the number of people on board and any medical needs, and initiate the necessary logistical arrangements like providing passenger transport and maintenance assistance. Let's now listen to the actual recording.
Iconic 719, you okay?
This
is 719, are you okay?
the tower saw the smoke and then trying to reach the...
Okay, yeah, we saw a lot of smoke and we heard a loud pop. Well, we're going to get the trucks out there for you.
Right, thank you. Yeah, it feels like a rough roll, so we might have a bird fire.
Okay, Roger. Yeah, we're assuming the flat tire, but we're going to get the trucks out just as a precaution.
Okay, thank you, Mr. 719.
And any Teterboro vehicle on frequency?
Teterboro Tower, Teterboro 99 is en route to runway 19 Golf.
199, Roger. And Teterboro 99, we're showing 19 closed as a heads up.
Teterboro operations copy, runway 19 closed.
And Teterboro 99, just be advised, it's by Old Delta, Lima, what is that, Lima 3 now?
Tower 99 from Lima 1, like 2 for runway 19.
Teterboro 99, proceed on runway 19 or cross runway 24.
Proceed on 19, cross 24, Teterboro 99. And confirm 19 is closed.
We're showing runway 19 is closed. And Vision 719, do you need to evacuate there or are you guys okay still?
We're okay. If we could just have someone inspect the undercarriage for any fire issues, and then we can take it from there.
Vision 719, no problem. They're on their way. They'll be there within the next 10 seconds.
So much. So we'll keep engines running. No further action from our side required. We just need an inspection of the undercarriage.
They said no bomb on their way.
And the Teterboro vehicle 99 and any fire trucks that are on the frequency, just be advised the engines are still running. You just need an inspection currently.
And Tower 99, if able, I'd like to take a look in the main intersection.
99, Roger. Proceed into the main again.
We will, going to proceed into the main intersection of 24, Teterboro 99. I'll report one off.
99, Roger.
They're copying every message.
So from our side, from Visit 719, we had some rapid acceleration without initial braking. So we just need to see if we might have hit something on the runway or Next step is to check that all our tires are still inflated and that the undercarriage is intact.
Visit 719, roger. And Teterboro 99, or did you hear that?
Yeah, Tower, Teterboro Ops copies. We'll inform the 99 he's out of the vehicle.
Yeah, roger. And, stand by. And, Visit 719, the fire trucks, the emergency vehicles are looking to talk to you on 125.1, and, you can relay all that information, and they'll relay more information to you.
Thanks, 125.1. Fire truck from Visit 719, how do you read? We had some rapid deceleration after touchdown without specific addition of the brakes, and then some movement, some uncontrolled movement to the right. So if you could check if all the tires are still inflated or if there's any damage, more specifically on the right-hand side. Our engines are all running at this time. You need them shut down. All right, we're all shut down now. Visit 719. All right, from Visit 719, engines are fully shut down. You might still hear the APU running, but that's no risk to him walking around.
APU is a auxiliary power unit.
Rescue 1, any update?
Rescue 1, aircraft captain.
Go ahead.
How many souls on board?
We've got 4 souls on board.
Okay, just making sure. Is there anybody in need of any medical attention at this time?
Negative.
Thank you.
Roger.
Right now, I just have the personnel doing the perimeter with a thermal imaging camera. Check the temperatures.
Thank you.
Teterboro 74, Teterboro ground, any update?
All right, thank you from Visit 719.
Rescue 1, Teterboro ground.
Aircraft captain from Rescue 1.
Go ahead.
All right, we've
All right, all copy. So you can confirm all the tires are still inflated. All right, thank you. Visit 719.
Rescue 1, Teterboro operations.
Rescue 1, guys?
Yeah, Rescue 1, Teterboro operations. Do you have a souls on board?
I believe it was 4.
4 souls, copy, thank you.
Do you have the status? Was it a tire?
Affirm. For what we see, as you guys are reporting, all tires are deflated. The surface check from Teterboro 99 came back clean, no debris on the runway.
No debris on the runway, but they have flat tires.
Affirm.
And do you know, you said all the tires are flat?
That is what the trucks on the scene are reporting us.
That's what they were reporting. Okay, thank you.
So just to confirm for Visit 719, we'll keep the doors closed until we see transport outside, or should we open the door already?
And 9 Hotel Victor Juliet Alpha, Teterboro operations, ground frequency.
We are on 1251, is this where you're calling?
Affirmative. I just wanted to let you know, we have a tug from Atlantic Aviation on the way, as well as a shuttle bus for passengers. I just wanted to make you aware, though, it looks like all 4 tires on the main gear are flat, so I'm not sure how tugging the aircraft's going to go.
All right, thanks. Yeah, I think we'll need to get in touch with our maintenance department as well and just confirm whether it's good to move. But for now, thanks for the transport, and we'll have the passage on as soon as it arrives.
Okay, roger that. And just be advised, we do have dollies at in our operations hangar. We have 2 of them that are rated for larger aircraft. So it's possible we'll be able to use them, but we'll figure that out once we get in touch with maintenance and everything.
All right, guys. Yeah, we'll make some contact with our guys and just get go ahead from both sides. Thanks for the help from Victor Juliet Alpha.
And 9H Victor Juliet Alpha operations. Can I just have an idea how many people you have on board?
We've got 4, 3 crew, 1 passenger. If we could just get shuttle out here for the passengers to keep them on schedule.
Copy that. Our bus is on the way right now, and copy 3 crew, 1 passenger. Thank you.
Thank you. So most likely the crew will remain on the aircraft for now, and then the passenger will just get to his connection.
Roger that. Thanks.
Yeah, all 4 tires are flat, no debris on the runway, and they have to switch to different radio frequency, and there's a lot of noises. It's not clear, so it is hard. Their job is hard. Yeah, let me stop. So I tried to take a look at how the current training is going on for air traffic controller. How do they get trained, and what kind of preparation they do that. So I went to the Santa Clara library, and I came across this e-book. So I want to give credit for the Santa Clara library, especially that library that I went to is at Los Altos. That has a wonderful set of machine learning, deep learning, all kinds of computer books, even the algorithms, and then the Python, Java, any kind of it is a rich collection of books. They have it. And they have a very good Wi-Fi. So this document I came across. This document will be very useful for you to train your model to perform the air traffic control task, to qualify to become your model to qualify to become a air traffic controller. AA air traffic controller. This is the beginning. This is the starting point. So they have a list of. So this book is a complete test preparation for air traffic control. Prepare for the selection and training test. Okay, so this is a very good document. So I went through this air traffic control test preparation. They have a list of contributors. Yeah, so Linda M. Bracewell, Greg Michael, Thea Binal, Mark J. Lewis, Timothy K. Trowbridge. So those are the individuals. You may need to get in touch with them. They could train your model, or they could train your developers, or at least the product managers. So they have a rich experience in this field. and they know the opportunities as well as challenges. So Linda is an air traffic control instructor at Minneapolis College, Eden Prairie, Minneapolis, where she has taught the basics of air traffic control to over. Okay, I'll let you guys read these and go through this information. So this person is a air traffic control consultant for UFA, an industry leader in air traffic control simulation and voice recognition and response. And level 11 TROCON, I think that is the RF frequency protocol or standard. Actually, they are having it. And Mark is a science writer, editor for algebra. Yeah, city school. Yeah, I think you go through these and then get an idea about that. But this book was similar kind of documents will be very useful to train your model. So it starts with overview of air traffic control and control system, weather and air traffic control. So that is another one. VFR. Oh, IFR. So I heard them talking visual, VFR and IFR. Is only here I get that information. Visual flight rules or instrument flight rules. Yeah. And analogless. I think that is more on the. Anyway, let's see that. So angles and applied math, that you guys are well conversant on that. Scan and dial reading. So this one is needed for only for human controller. Machines are able to do the scanning and dial reading. So that should not be a problem. So you guys have to, your model needs to learn overview of the air control and air traffic control system, weather and air traffic control, charting and air traffic control. I don't know what is this one, but let's see. So you can skip these angles and applied math, and you can also skip scan and dial reading, and you can also skip these letter factory and air traffic scenarios. So they actually, these things are to see whether human is alert and then ready to process the information. So that part. So they prefer to recruit young people around 30 years age, and then they should be able to respond effectively for those challenges. Okay, so I'll browse through this, and then you guys take a time and then read it carefully on this. So FAA, they have very good document publications. Federal Aviation Administration, FAA.gov, GOV. Okay, that is the domain. You should be able to get a lot of information on that. Let me just read this first paragraph. Years ago, only a few planes flew across America's sky. So, air controllers, people in towers and on the ground who monitor and control the flow of aircraft into and out of airports were unnecessary. Even now, some of the countries in some of the airports they don't have air traffic controllers because there is the traffic is very less and the space is they have wide open space, remote place, so they don't have air traffic controllers. And if the visibility is good, then the pilot can, just like parking a car, they can land and take off. Times soon changed, however, as more and more planes transported people and goods. From state to state and from country to country, it became apparent that rules were needed to avoid collisions. That is true. So on May 1926, the United States passed the Air Commerce Act. So your model needs to train on all these information also. Air Commerce Act, which called upon the aviation industry to improve and maintain safety standards. The Act also put the Secretary of Commerce in charge of creating and enforcing air traffic rules, licensing pilots, inspecting and certifying aircraft, creating new navigation aids. Yeah. The first rules regarding aviation were extremely simplistic, perhaps even humorous compared to today's standards. One rule asked pilots to look around before taking off to avoid hitting other planes. Yeah. Okay. As air traffic increased, airport operators realized that they could not rely solely on pilots' eyes to avoid collisions. Using visual signals, they created an early form of air traffic control. They hired flagmen, men who stood on the field waving flags to communicate with pilots. So that is how they started. When aircraft began using radio communication and radio-equipped ATC towers replaced the flagmen. In 1930, okay, that is 70 plus 20, okay. Oh my goodness. 2030, will be soon 2030, 100 years, okay. The first radio-equipped control tower in the United States began operating at the Cleveland Municipal Airport. Soon, many more airports across the country had built control towers. Today, the Federal Aviation Administration, FAA, employs approximately 24,900 air traffic controllers who are responsible for directing the flow of air traffic and ensuring the aircraft fly at a safe distance from one another. Around 25,000 air traffic controllers are needed in United States. That picture is initial flagman, and this one is with the radio-equipped control tower at the Cleveland Municipal Airport. So now we are in 2025, in another 5 years or soon before that, 2030, we should have artificial intelligence ATC, Air Traffic Control System. Let me read this also. This is an important one. Being an air traffic controller is not easy, and the job is not for everyone. It's a high time. They should be relieved. Humans should be relieved from this responsibility. Controllers are part of an air traffic control system, a vast network of people and equipment whose purpose is to ensure the safety of aircraft and passengers. Souls. A controller must work quickly and efficiently. There is little or no margin for error. Once in a while, it is okay. Human could do that, but not every day and every moment. They are under tense. So I could sense those air traffic controller. They were actually with concern. They were trying to reach out to the pilot. JetBlue 637, are you with me? I saw the smoke coming from your aircraft, and then and then all tires are flat, no debris on the airway. So all those things is not manageable by human ATC. So they must concentrate fully on several planes simultaneously to ensure that pilots receive the correct instructions during arrival, and then the RF communication is very noisy, and multiple listeners are there. They have a protocol. They're talking one at a time. But the pilot has to connect to different frequencies during their flight. Even within the airport itself, they have to connect to different frequency. And when they connect to a different controller, they have to provide the same information. What is the pilot? What is the aircraft? And who is the pilot? And how many crews? And what is the fuel capacity? And how many souls are on board? So all this information should be available on the platform. Like you go on to a X platform, you get the entire profile of my profile. So those kind of that information, there should be a platform. They don't have it right now. So when you talk about the platform, I don't know what messaging platform Google has it. So Google, I'm not sure about the Google, and OpenAI doesn't have any of those platforms. WhatsApp, Meta has a WhatsApp, and X platform. I think that will be the best one. That is the best. So they could actually build clone the X platform and then give it to the aviation folks. So every transaction, every trip is a transaction, and the controller should not seek information from pilot. They should know that, oh, okay, this flight is loaded with this much of fuel, and they have traveled. This must be the fuel available on the aircraft, and the souls are the passengers are these many. So those information should be available from the platform, not from the pilot or from the controller. Controller, okay. During arrival and departure rushes, the job can be stressful and exhausting. I could sense that during the holidays, when there is a people are on travel, So that must be a peak situation. During non-peak periods, however, controllers enjoy a relatively calm work environment. That is good. Okay, they deserve it. Okay, controllers use radar. So now you have a vision camera, and then the intelligence is able to process the vision and could provide all the information. So your artificial intelligence, then drones, then Optimus robots, what else? Voice communication, voice AI, all would be in effect here. Now, I was actually talking to my alumni friend that from the airport, they could send a drone to the aircraft and to the pilot or into the cockpit. And the airport can take control over the flight and then safely bring it down on the runway. Or the drones could provide the information about the weather, altitude, digital information. They don't need to depend on the ILS. That's an analog one. And in worst case, drones, in case of hijack, drones could deliver weapons to the pilot at the cockpit. And the drones could be decorated like a eagle or a falcon and trained to chase away the birds from the airport surroundings. And your Waymo kind of a Waymo autonomous vehicle and Tesla also, they use a light radar, and then the Tesla is purely on the vision. So those they can actually sense the uh, bird attack before it comes close to the aircraft, and then they can take action. They could actually identify, oh, this is a bird, or this is just a dust. All those things they could actually sense it. So controllers use radar, but they sometimes rely on their own observation to guide pilots safely to and from airports. I don't know how do they manage it. If at Kennedy Airport, if the weather is bad, even the controller at the tower, they cannot have a clear visibility on the runway. So, yeah, so all these challenges are there to guide pilots safely and to and from airports. For example, a controller in a control tower might visually observe air traffic coming into and going out of an airport. So, yeah, so those are the challenges. Controllers work very hard, but they are well paid and receive excellent benefits. But still, I heard that they are of the age of 40, and then because you hand over them the life and death of 182 souls on board, the one single soul, how could it take that burden? And many air traffic controller, I think especially the tower controller, they have more burden than the ground controller. They die out of heart attack and then situation. So many it is a high time. Intelligence needs to take over the responsibility. And it's good that Secretary Sean Duffy highlighted the need for this. So artificial intelligence is an unsatisfied need for aviation industry. So controllers work very hard, but they are okay. Many control towers operate 24/7. See, they don't sleep at all. This is a global mess actually, and 365 days a year. So controllers have opportunities to earn. Yes, you have to pay them. Well, so they typically earn an additional. Okay, I'll skip that part, earning part. FAA employees. We are not employing the AI. We are not introducing AI to save money on salary, but to take the burden out of human beings. It's not about saving money, but ultimately it saves a lot of money. Yeah. FAA employs most work at airports, but some work at air route traffic control centers. So that is another part. So this video is all about overview on the aviation industry, and I gain confidence on the ground controller and then the tower controller. This I haven't gone deep into it. On the route traffic control system, they have the centers in many different states. So I will publish a series of video in coming weeks. So currently I'm focusing only on the aviation industry domain. I'm not focusing on any other domain. So I am deep into it. So I'll cover each individual part in detail. First, I need to learn their domain, but sources are available. So and then present to you guys to the Silicon Valley in their language. So this one, yes, route traffic control centers, ARTCC. I have not gone into it, but I will actually follow up in coming videos, which are located in various places. Some controllers conduct research at the William J. Hughes Technical Center near Atlantic City, New Jersey. A small number of controllers work for the Department of Defense and private ATC companies. Okay, so then your model needs to be trained on the Act. What is that one? Air Commerce Act. So United States passed the Air Commerce Act. That needs to be trained. And then the NAS. So that also your model needs to be trained. The United States maintains the National Airspace System, the most complex aviation system in the world. This system is an enormous network of people, facilities, and technology. I have visited their website. It needs a lot of improvement. Yeah. Included in NAS or controllers, airport personnel, airports, air navigation facilities and equipment. The goal of NAS to ensure safe air travel over the United States and over oceans throughout the world. Air traffic controllers work primarily in 3 different environments. Air traffic control towers. This is at the airport, and then the terminal radar approach control facilities, TRACONs. I think this is close to the airport, and air route traffic control centers. This is if the flight is going from San Francisco to New York, they have to get in touch with multiple air traffic control centers in their route. So each one has a different frequency. They're all a radio communication. So all these 3 environment has to we have to bring them into a common aviation platform. Global, that would be better. So you cannot, because you have a international travel, so you need to bring the that platform could be restricted, and the scope should be limited only for the technical side, engineering side, not for booking and hotel booking, and then security, all those issues. Security means that going through the individuals. So that should be on the other part of it. Homeland security, or they can let them take care of it. But this should be this platform should be only for engineers. If you have been to an airport, you have probably seen an air traffic control tower. Yeah, so we have in several places we have control. We have covered these part. Terminal radar approach control facility may be located within an airport, or it may be located miles away from the airport. Maybe a single track on this facility would be supporting both San Francisco, Oakland, and maybe even San Jose Airport. I need to verify that. So this I'll cover in another video. So then we come to this. You learned earlier about the traffic, and direct traffic flows smoothly out on the airport. So this one is about the airport. A controller may be one of 2 types: a terminal controller and en route center controller. Terminal controllers who work in ATCTs, or called ATCT controller. Those who work in track-on facility, track-on controller. ATCT controllers separate departures and arrivals. And the track-on controllers separate aircraft when they leave ATC airport prior to entering, all those things. Okay. So this is different centers. Okay. So local control. They are specializing, perform the following duties: issue landing and takeoff clearance, issue landing information, runway, wind, and altimeter, sequence landing. I think this local controller is a tower controller, maybe. Sequence landing traffic, coordinate with other positions of operations. They coordinate with the ground controller and other controllers, issue weather and no-term notice to airman information as necessary. So I will cover the weather and all these related functions in a separate video. and operate runway and approach lights, receive relay pilot reports. And then the ground control, they can specialize in ground control, is mainly responsible for separating aircraft and vehicles uh, on inactive runways and taxiways. This position, this responsibility is less stressful, I could say that. They are responsible to move the aircraft from the gate to taxiway and issue clearance for departure. So all these things are here. And track on, they have a departure controller and arrival controller. See, there are so many different responsibilities. You could, for each one, you can build a AI agent. And I see that this land graph swarm architecture that maintains a state and transfers state from one agent to another agent. That would be a wonderful thing. Qualities of air control. So these are all goes into in depth. Let's see whether you are AI qualified to become a AI-ATC. You are not a human, so you can be any. The citizenship doesn't. All right, and you speak English clearly. Your voice AI. If your voice AI is not stable or is not matured or qualified, and then you cannot enter into this field. So make sure that your voice AI is perfect, and you should be able to listen US English, Europe English, Asian English. So coincidentally, all they use English, and then the limited words. So it should be okay. So you don't need to do an interview. You have you have to go through this training and experience. Even AI should have a test. Be hired. So you don't have a age. That is an advantage. Once you are trained, and you can work there for generations, your AI. And you don't have a medical examination and the security. So you are qualifying it, yeah. So that is a good part. Flight service specialist, okay. Okay. So this part is angles and okay. So yeah, so the analogy test. Oh, so an analogyless, okay, measures your ability to reason well, an important trait for an air traffic control. So reasoning, your intelligence and reasoning. So this is an analogy. Okay, when they say hot, you have to say cold. When they say short, you have to say tall. Yeah, okay. So I think this you will qualify. So there will be a test, so you will qualify. Applied math, I don't have a issue with the computer, so you should be okay. Scan test also, you will read a range of numbers such as 102560 that appear at the bottom of the screen, and you watch as blocks of data appear. Yeah, I think these are all you will be able to qualify. Pre-plan and make letter factory and all these things. Okay. Yeah. So you'll be asked to respond to a statement about yourself using the following scale. Definitely true, somewhat true, all this. This is what you do it in your transformer or a reinforced training, a set of vectors, definitely true, somewhat true, neither true, all those things. Yeah, so based on the features, yeah, okay, so you have a vision and you don't have a heart. And you don't have, you are good at psychiatric, yeah, so these are all good for you, yeah, for the, I'm talking in favor of artificial intelligence, okay. So there will be a quiz. So what act required the aviation industry to improve and maintain safety? Say Air Commerce Act. Yeah. I don't want to test myself. Okay. So here the control system. Okay, I think I will cover this also. So the culture terminals. I want to take you to that. Okay. So you will be the you have to train your model with all these acronyms, IFR, VFR, and all those things, and you should be able to understand what is the entity and their relationship, power transmission line, prominent pictorials. Your vision has improved a lot, so you should be able to recognize all these things, and I'm confident on that. Rotating beacons. Most airports and heliports, small airports, have high intensity light called rotating beacons. Beacons that appears as a flashlight when viewed. I think they are actually sending Morse code or yeah, ALS approach lighting system and sequential flashing lights. So these, yeah. So your model needs to be trained on all these things. Post radio range, land and short lights, navigation. Okay. So yeah, so these are the acronym. VHF omnidirectional range, VOR. I can't. So I will cover each one in a separate video. VOR one video and DME, NDB, non-directional radio beacon, and automatic direction finders, ADFs, tactical air navigation. So I think this is from the Department of Defense, but that's a kind of a standard. This is their vector airways and then the jet routes. Yeah, okay. So this information is about the radar. GPS. I think now we could use a GPS, and for mobile we are using their cell towers for accurate positioning. So you could have more positioning towers or drones. Drones could give vertical positioning. So yeah, I haven't gone through this part. So I'll cover them as well as your model needs. This book almost the entire thing. Your model has to be trained on this content. What are the different airspace? So, okay. Now we are coming to the radio communication. So controllers must communicate clearly with pilots so that pilots have the information they need to maintain separation and safely operate aircraft. Any misunderstanding between controller and pilot could result in disaster. Controllers and pilots most often communicating via two-way radio. That is what is happening. And most of the conversation are supporting. They support each other and it was cordial. I came across one or a few conversation where they were getting into kind of a conflict. So in one, the controller says United 1469, but the pilot says 1469. And then there is a call sign. They have to repeat it, and then the pilot was missing it. The controller was got angry, and the controller mentioned that to the pilot that you need to contact this phone number, and they are giving a phone number. That means that uh, he is gonna they have a session with them. So that is also happening. So so the very initial focus should be on the phraseology. Phraseology. So it's kind of this is what they globally they are using it. They said that even within Germany, the pilots are the German citizen and the control towers they are also German citizen, but they have to talk in English for aviation. So at least that part we have no confusion. One standard English, their English, the phraseology English. So that is should be a easy one to train your model. So it is starting here, phonetic number and phonetic alphabet. 0, 0, 1, 2, 3, 4, 5, 6, 7, 8, 9, 9. Okay, see, they don't say 9, 9. And the A is alpha, bravo, bravo. Oh, yeah, I heard them using bravo. Okay, that is B, Charlie, that is C, Delta, Echo, FOKS-TROT. Oh, I heard it. I thought that some I couldn't connect to the it's a F letter, Foxtrot, golf. Yeah, so they have a confusion because they are writing with a pen. They have a confusion. One pilot was running into confusion between golf and Oscar. Whether he was not sure whether it's a O or G. Golf hotel. Oh my goodness. I heard them in their conversation. I thought that they are really referring to the hotel because that flight and hotel are connected. I thought that, okay. Hotel, India. Oh, okay. India, Juliet. Juliet, then there is a Romeo. Okay, Romeo is also here. Juliet. Kilo. 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 Lima. Oh, yeah, I heard that. Lima. Lima 3. Or something they were asking. Mike, November, Oscar, Papa. That is for P, Quebec, Romeo, Sierra, Tango, Uniform, Victor, Whiskey. I heard whiskey several times. Okay, W for whiskey, X-ray. Oh, Okay, I heard them talking X-ray, but I was referring to okay, Yankee. Yeah, that I heard it. Zulu. For Z, they use Zulu, but timing also they use Zulu. We have to understand. So you have to train your model. So your model should able to speak in their language in Romeo, Bravo, Charlie, and when they speak, your model should be able to uh, translate. So there you already have a language translation. This is one more language translation. So your transformer should be able to say that. And then they say the numbers, a separate one, not as a 10, is 1, 0. 1, 1, 0. Okay, see. So those things you need to try. 1, 2,000. 12,000, they're calling us 1, 2,000. 2,500. Okay, so that is about numbers and alphabets. And the time is UTC. But so you are comfortable with that, yeah. So that is not a problem. When I say you, it is artificial intelligence, and I'm talking to your models. OpenAI, Google, Grok, Meta, and who else? Okay, flight levels. Yeah, okay, MDA. Yeah, I wanted to mainly focus on this phraseology. That is easy and fun to learn. And all these, their speeds in terms of knots and frequencies, you know that. We could get rid of this frequency. Once you have the platform, we don't need to ask them, okay, you connect to this frequency and all those things. Okay. Center, air traffic control center, they call it a center. Approach control is approach. Clearance, delivery is clearance. Departure, flight service station, that is radio. Flight watch, ground control, ground tower. Local control is tower, yeah, okay. Aircraft identification is a ACA. JetBlue, I came across JetBlue. United, okay. Delta, American Airlines. So, yeah, so call sign, yeah, the call sign that needs to be part of your every communication. Okay. Yeah, so there is a quiz. So your model should be able to take this quiz and qualify. Yeah. So I'm not going to cover the weather. I will have it as a separate video. And what is this one? Weather. Meta. Okay. Charting and air traffic control. VFR and IFR. Okay. This I'll cover in a separate video. Definitely. Yeah, space and the entire part of it. Yeah. So this is an important one. There's analogies I don't think your AI needs to know. So we can skip that part. And math and angles. These are all you guys. You. I don't need to say that. Yeah. You are the expert. Aircraft is descending 1,275 feet every 3 seconds. How many feet will it descend? See, these calculations they are doing. So your platform should support. Yeah, so this part, I'm not going to cover it, but you should be able to do this part. I have confidence in applied math. You guys are good at it. Okay, I think we are very. Yeah, so you know all these formulas, mathematics. It is not complicated as your linear algebra and matrix multiplication. Okay, scan and dialing. This also is for human. Yeah, so see, they actually have the number on the bottom represents the speed of the aircraft, as in the example. See, this is the screen they have it here. So this is not good. So it should have a vector, and then it should clearly highlight the altitude. See this and this. We couldn't say that whether. See, everything is your model, your transformer model, large language model is built on a sequence to sequence model, and their aircraft movement also sequence to sequence. Weather is also sequence to sequence. So you should be able to build a vector. And when we see that, okay, we should be able to predict the next weather, next position of the aircraft. So we should know that the altitude and the speed, and then we could say that, oh, this will hit with this V90 will crash on air A48. So we should have a vector. The screen should clearly. This is a kind of a black screen. So we should bring the altitude all in a graph, and we should able to predict it. Okay, there's going to be a crash, or this is going to be a save. This information is not good enough. Yeah. So all these analog telemetry or meter, we should replace it with the digital and then the vector. Vector, not a row column, not table. Okay, I think we are good, I guess. So this is compared to your other training and all those things. You should be able to train your model to qualify to become a letter factory. I think this is the last one. Okay, what letter was? I think these are all to see the alertness. Must assess information such as on radar screen and make good decision based on what they see. So that is for humans. So you don't need these letter factory and air traffic scenario. So you are good at it. Okay. Then that's it, I guess. Once you train your model on phraseology, then you you take all the audio recordings of the previous recording. There is a site called Live-ATC that provides you all the recording, live recording also. That should be able to train your models. Okay, I think that is the end of it. So this is a JetBlue 967 aircraft. These are audio recording captures radio communication related to JetBlue 967 experiencing a complete engine failure shortly after takeoff. The pilot calmly informs air traffic control of the engine tube failure and requests a return to Kennedy Airport. ATC provides vectors, altitude adjustments, and runway information while coordinating emergency services in anticipation of a possible fire incident. The recording concludes with the aircraft approaching Kennedy and the crew preparing to assess the external conditions upon landing. Ensuring passenger safety is prioritized. Now let's listen to the recording.
JetBlue 967 Western Star. Wind is a 180 at 3. Runway 34, clear to takeoff.
Clear for takeoff 34, JetBlue 967.
JetBlue 967, contact departure.
Good day, thank you, JetBlue 967. And Tower 412 Romeo, it looks like that JetBlue just had an engine problem.
Thank you. JetBlue 967, you still with me? JJ380, I'm just going to hold you short of the runway till we figure out what's going on with JetBlue.
JJ380, ready.
539, you on me? We're not sure if the JetBlue hit a bird or not, but can we get a runway sweep just in case? JJ380, just a few more minutes. We're just going to get a runway sweep.
Okay, no problem, JJ380, thanks. Departure JetBlue 967, we just got an engine failure. We're heading 330 and maintaining 2000.
JetBlue 967, radar contact. Climb and maintain 7000, turn left heading 260.
We just got an engine failure. We're going to request vectors back to Kennedy, please.
All right, JetBlue 967, you can stop your climb and fly heading 090.
Heading 090 and stop climb at 2000, JetBlue 967.
And JetBlue 967, I just want to double check, you said an engine failure?
Yeah, complete engine failure. JetBlue 967.
All right, go ahead and take some time, and when you can, tell me which engine it is. Sold on board and fuel remaining.
Yeah, engine 2 fail, and for now it's under control. Number 1 is good. And yeah, we're going to maintain 2000.
Okay, JetBlue 967, no problem. You want to head back to Westchester or you want to go somewhere else?
No, we're under control for now. We'd like to go to Kennedy, please. JetBlue 967.
JetBlue 967, you're cleared to Kennedy Airport via radar vectors, fly heading of 160.
Heading 160, JetBlue 967.
JetBlue 967, information, Romeo is current at Kennedy. They're landing runway 22 left and right. The winds are 180 at 7. Altimeter is 2986. And I can get back to you shortly with the runway assignment, unless if you know what runway you want.
Roger. We'll let you know in a minute. We're going to figure out the engine first. We're going to secure it, and then we'll text you again. We'd like to request a climb to 3000.
JetBlue 967, climb maintain 3000, heading 160. Would you like some delay vectors?
Sure, please. JetBlue-967.
Okay, JetBlue 967, maintain 3000, heading a 160. You can expect a couple turns. Let me know when you're ready to head that way.
Roger. Climb to 3000, heading 160, 3000, JetBlue-967.
And JetBlue 967, when you can, fuel and souls on board.
Bye. 22,000 pounds, and we got 133 souls on board, JetBlue 967.
JetBlue 967, roger. And climb to 3000, contact 125.7. They're going to give you a spot to hold and figure everything out for you.
25-7, JetBlue 967, and climb to 3000. Thank you.
JetBlue 967, are you here?
Yeah, 967, 3000, heading 160 with engine failure.
JetBlue 967, turn heading 220 for traffic.
Right heading 220, JetBlue 967.
JetBlue 967, I'm just going to give you some vectors here until you're ready. You let me know when you're ready to come in.
All right, let's do JetBlue 967. We'll continue with the vectors. We're going to secure the engine, do some checklists, and then we'll get you back.
Thank you, no rush. JetBlue 967, which engine is out, left side or right side?
The right side, JetBlue 967.
Thank you. JetBlue 967, I know you're running checklist now, but if you need a runway other than 22 left, just let me know so we can coordinate.
22 left is fine, JetBlue 967. And New York, JetBlue 967, we're ready for the approach now.
967, thank you. Turn left setting 280. I need an update on the fuel in pounds if you have that, please.
All right, the fuel right now is 20,700 pounds, JetBlue 967.
Thank you. 280 heading vectors, ILS 22 left.
All right, 280 vectors 22 left, JetBlue 967. And New York, JetBlue 967, just to confirm, we declared the emergency just to get the trucks ready for us, just in case.
Yes, sir. I'll make sure the trucks are out for you.
All right, thank you.
They're there, sir.
Thank you.
JetBlue 967, 11 miles from Zalpo, turn left heading 250, maintain 3000 until established localized cleared ILS runway 22 left approach.
All right, heading 250, 3000 to established cleared ILS 22 left, JetBlue 967.
JetBlue 967, contact Kennedy Tower 119.1.
All right, 19.1, JetBlue 967, thank you. And Kennedy Tower, good morning, JetBlue 967, ILS 22 left.
JetBlue 967, Kennedy Tower, good morning. Emergency equipment standing by, wind 2208, runway 22 left, clear to land.
Clear to land at 22 left, JetBlue 967, thank you.
JetBlue 967, turn right hotel, hold short of Yankee, do you require any assistance?
All right, hotel, hold short of Yankee, can you ask the ground trucks to let us know what's the condition outside, if it's fire or smoke?
Okay, JetBlue 967, roger. Hold short of taxiway Yankee. Switch to ground 121.65 for the communication.
All right, hold short of Yankee and 121.65, JetBlue 967.
Yeah, that was JetBlue on the Kennedy Airport. So the pilot gave the fuel 22,700 pounds to multiple time. We need to bring them into a platform, aviation platform or air traffic controller. This is United Airlines flight 1544. This audio transcript captures radio communications regarding United 1544, a flight experiencing an in-flight emergency due to low oil pressure in its left engine. The pilot declares the emergency and requests to return to the airport, receiving vectors and instructions from air traffic control to set up for landing. After working through the checklist, the flight ultimately executes an ILS approach, instrument landing system approach, and lands safely on runway 22 left, with the emergency services alerted and standing by to provide assistance on the ground after landing. Now let's listen to the recording.
Yeah, 1544 with 2406, 2 started Whiskey, clear for takeoff.
Clear for takeoff, 22 right at Whiskey, United 1544. Tower United 1544.
Yeah, 1544,
Yeah, we'd like to return to the field.
Okay, do you want to do it VFR or IFR?
Let's do it IFR and I'd like to declare an emergency.
Okay, what is the emergency?
Low oil pressure on the left engine.
Okay, we'll loop you back around. I'll call approach now, let him know. Switch to them on 2855.
Okay, going to departure. Departure United 1544.
1544 near departure, radar contact. You want to come right back in and do the visual?
That's affirmative, United 1544.
United 1544, roger, maintain 3000, turn right heading 340.
3,340, United 1544.
United 1544, continue right turn heading 030 and advise any other field in sight.
Alright, 030, United 1544. We might need a little bit of a downwind to run some checklists.
How long of a downwind you think?
I'd say about a 10-mile downwind.
Okay, sounds good. 030. United 1544, turn right heading 040.
040, United 1544.
And like I said, when you're able, souls on board and fuel in pounds, please.
New York 3 United 1544, 182 souls on board, 7 hours fuel.
Okay, fuel in pounds.
50.3 for United 1544.
United 1544, roger. Let me know when you're ready to come in.
Will do, and we'll be single engine for United 1544.
Okay, and which engine is out?
Number 1, left engine.
And you going to be able to get off the runway, or are you planning on stopping on the runway?
As you know, we'll be able to vacate 1544.
Okay. United 1544, turn right heading 120. It's the base leg, but if you're not ready, I'll just box you back around.
120, yeah, we'll need a box for 1544.
Okay, how much longer do you think?
We'll advise 1544. New York 1544, appreciate your help. We'll need about 5 more minutes.
United 1544, thank you. United 1544, turn running 270. I'm just going to box you around and keep you kind of near the airport so you can get right in when you're ready.
Approach United 1544, is it 240 heading?
United 1544, heading, you can make the heading 290 now. And like I said, I'm going to try to keep you right here next to the airport so you can get right in when you're ready.
Alright, 290 when we're ready to come, and we are ready to come in for United 1544.
Okay, expect a right turn back around for the visual unless you want to go straight in there.
No, we'll take the right turn around for United 1544.
Very good. United 1544, the tower, they're asking if the engine went out on its own or if you turned it off.
No, we just set it down for no oil pressure, United 1544.
I'm sorry, you said that you shut it down?
We set it down for no oil pressure.
United 1544, very good. Continue the right turn, heading 090.
090, United 1544.
United 1544, the tower, they're asking if the engine went out on its own or if you turned it off.
No, we just set it down for no oil pressure, United 1544.
I'm sorry, you said that you shut it down?
We set it down for no oil pressure.
United 1544, very good. Continue the right turn, heading 090.
090, United 1544.
United 1544, the field is 2 o'clock at about 10 miles. If you don't have it, I'll have a vector to join the localizer for you.
Alright, we'll take the vector to the localizer for 1544.
Okay, very good. 1544, just going to maintain 2,500.
Down to 2,500, 1544.
United 1544, you want the ILS or you got the field?
ILS, please, 1544.
And 1544, a mile from Gimme, maintain 2,500 till established on the localizer, cleared ILS, runway 22 left approach.
2,500 till established, cleared ILS, 22 left, United 1544. United 1544, contact tower 118.3.
18-3, thanks for your help, 1544.
Anytime. Tower United 1544, ILS-22 left, emergency aircraft.
United 1544, Newark Hello, wind 2303, only 22 left, clear to land.
22 left, clear to land, United 1544.
And just be advised, there will be, after you land and touch down, a Port Authority vehicle is going to follow you down the runway.
Okay, 1544, thank you.
Car 99 at Mike, proceed on runway 22 left.
Mike, 99,
United 1544, November, cross runway 22 right, you can join Alpha to the ramp with me.
November, cross 22 right, Alpha to the ramp with you, 1544.
And would you like any assistance?
None needed as of now, thank you, 1544.
You got it. You can monitor ground on the way, and if something changes, let him know.
Okay, monitor ground, thanks for your help, 1544. Just to confirm, we're clear across 22 right?
Yep, 1544, November, cross 22 right.
November, cross 22 right, 1544.
Car 99, all 22 right.
Car 99, roger.
1544. That was night. Aircraft. Yeah. Let me share with you guys how did I start learning about air traffic controller. I started with a book, e-book from the library on how the human are preparing for the test. Mostly start with the phraseology. Then I actually visited a website. So that is a AI-ATC. LEE-ATC.net. And then I was listening to a sub. Yeah. So they have the live feed. You could listen to. Go to the mobile. So I think that is it. Okay. Yeah. So there's a phone. So this is live. I get the ground to tower. Oh, sorry. Okay. Okay. Yes. Ground delivery, ground gate, ground tower. Just want to let's listen.
charted visual flight procedures in use. Landing runway 28 left, 28 right. Departing runway 1 left, 1 right. Bird activity in vicinity of airport. Advise on initial contact. You have information echo. San Francisco International Airport ATIS information echo. 2256 Zulu. Wind 300 at 4. Visibility 10. Your clouds at 3,000, 4,500 megahertz, ceiling 5,000 broken. 10.
So that was so that live-ATC.net has all the resources. They even have an archive of all the recordings. So you should be able to download their recordings and then train your model. I extensively use Google Notebook LM language model. So I created the air traffic controller model, and I have uploaded all the documents, air traffic controller training PDF, and if I click on that, it gives me the summary about the document, and I should be able to ask questions on that. I extensively used the notebook LM model, and this is AIM, aircraft instruction manual or something. Oh yeah, aeronautical information manual. So this is a notebook LM is an excellent. It's not for developers. It's for exploring things like that. But should be a good tool for senior management, chief executives and vice president directors. That should be good. And FOW-ER, and here all the recordings. So this audio captures the radio communication between air traffic control at Westchester Tower and various air. So so this one actually gives you the voice to text information. So I can actually ask questions. What yeah, I think that's okay. Yeah, so it's giving. See, that is a good part of the language model. It's a aircraft slide off the end runway. So you could actually ask for all those information. And there's another PDF and all these recording United Aviation. So this tool really helped me to. Without this tool, going through all these manual and other things would have taken a time. And they also give a audio overview. It is a good one actually. I think they're still working on it, so it's called the beta. Okay, or listen.
Welcome back to the Deep Dive. Today, we're going to be looking at how the FAA trains its air traffic control specialists.
Buckle up.
You provided us with excerpts
AI,
from the FAA order
not a human.
JO3120.4S.
Yeah.
Which really lays out their entire training and certification process.
It's a fascinating look at how they get these folks ready to do one of the most
stressful,
important jobs.
Yeah,
stressful and important jobs in aviation.
Absolutely. It's not just about directing planes, right? We'll be looking at everything from classroom instruction and simulations to on-the-job training.
It's a whole system to make sure that everything runs smoothly up there in the sky.
Okay, well, let's jump right into it. So first up, the training phases.
Right.
From what I understand, it's a multi-stage process.
It is.
It all starts with initial qualification training, or IQT.
You got it.
IQT.
IQT. Oh,
and it's like a ladder. You know,
Yeah.
each stage builds on the one before.
And the trainees get more and more responsibility as they climb higher and higher.
Gotcha.
So, for instance, like if someone's moving from just a tower to a combined tower TRACON facility,
Right.
they have to go through what's called terminal basic radar training.
Oh, wow. So it's very specific.
Very specific.
Okay, and speaking of specific, the training is also tailored to the different roles within air traffic control.
Right.
Right.
So we've
Share
got tower,
all this,
we've got TRACON,
Yep.
en route, flight service. Are those the main?
Those are the big ones, yeah.
Okay.
Each one has its own
description.
unique set of requirements.
They also
And
have
it's
an
fascinating how
interactive
they actually adapt the training to
I
the
tried it, but it was not working properly. Okay. Yeah, I think that would be a wonderful thing. So,
Welcome back to the Deep Dive.
Oh, hey, I think our listeners got something to say.
yeah, so hi guys. So that part is not working. It's okay. I'll share it. And I also share the GitHub. GitHub, I have collected all the reference materials. And I also tried to create a sandbox to test individual functions like audio to text. And this code was generated from Grok. I tried Meta. Meta actually put the try block somewhere here, and it was a syntax error. But the same format. So it is actually, it's calling the code speech recognition. It's calling the Google API. Recognizes speech recognition is from Google, I guess. Let me also share with you the lab. So I installed the speech recognition and PyTab. And since I have that MP3 file is not WAV file, so it was doing the conversion here. And then the audio source, and they recognize Google and gets a text. So let me share all those code also with you guys. And then the training data set. So I have all these recordings and then the text, what I have. I need to check in the latest one, but I will do that. And I also try to create a phraseology, a dictionary. Zero, how do you pronounce it? Zero and alpha. So that you could use those kind of things. So I just want to give an overview on this part. And then, yeah. Okay. So then I will to mention we would publish a series of video on other parts of the aviation, ILS. You should have a even co-pilot, the real co-pilot on the plane, on the flight, dedicated for communication only. That is not possible. The AI could do that. And some aircrafts are heavy and some aircrafts are light. When those combination of flights are in line for landing, then the tower ATC needs to apply intelligence to place aircrafts in sequence. Because that heavy aircrafts disrupts the runway surroundings. So ATC needs to give time for the runway surroundings to settle down before landing the next flight. So those kind of interventions, AI could do that. And Google Notebook language model is not for developers, it's for senior executives, CEO, vice president, director. They could upload documents. The tool could generate. I uploaded the aviation, the AAM manual, but I don't know what to ask for. I could ask for summary, but I don't know what else to ask. So if you could provide me a set of questions, that would be of help. So I uploaded AAM manual, but I had no idea what to do. So, an audio overview with human joining. This audio overview is a good innovation, but you have to make this to work. So if that works, then we could actually, the learning will be easier. Currently, it is not stable and not reliable. The human joining, audio over, everything is sequence to sequence. Flight movement is a sequence to sequence. Weather is sequence. And your model is sequence. You could fit very well. Flight movement is also sequence to sequence model. You could predict the next state in the movement, whether it's going to take off or climb or go in transit well. You could predict it. You could have a better control on the movement. Proof of concept of this AI would be validated at the academy in Oklahoma. Yeah, so that is possible. And I'll provide all the link in the description. And, I think I have covered. See, SpaceX, we could send rockets and capture the return flight with the chopsticks. So we have that kind of a technology. So your tower ATC could send a drone to cockpit, either take control of the aircraft or provide navigation for safe landing. And drones built like Eagle or Falcon, autonomous, trained to keep birds away from them. RTF, radio telephony, we should get rid of it. It's too noisy and weird sounds, headphones. See, it's irritating. Screech sound is coming. So we need global aviation platform, all airports and flights be on the platform. At the beginning of the trip, transaction profile will be created with information such as fuel, crew, other souls on board. At present, pilot needs to repeat the same information to multiple ATC. X platform, WhatsApp platform, all for exchange of messages, chat, voice voice AI is a need. Without that, you cannot do that. I think this is I've covered extensively. My objective is to bring Silicon Valley to the domain of the air traffic controller. That's the objective of this video. I will also cover the rest of the part of the aviation, but I'm confident that the technology is available and there's a need. So we should able to bridge the gap. All this video recording is all amateur, and then let me give credit to the libraries here. So okay. Well, I will end the recording. And it was fun. The learning was good. And I may stop recording.